right now, inside the 37 trillion cells of your body. Millions of damaged proteins, malfunctioning organelles, and toxic cellular debris are quietly accumulating. Think of it like a house that has not been cleaned in decades. Dust in the corners, broken furniture piling up, mold growing in places nobody can see. Left unchecked, this cellular garbage becomes the biological foundation for cancer, Alzheimer's disease, Parkinson's disease, and accelerated aging. The remarkable thing is that your body already has a built-in cleaning crew for exactly this problem. That system is called autophagy, and the switch that turns it on most reliably is a 16-hour fast. The word autophagy comes from the Greek for self-eating. In 2016, this cellular process was awarded the Nobel Prize in Physiology or Medicine. The Nobel Committee described autophagy as a fundamental process for degrading and recycling cellular components, essential for life itself. The awarded scientist spent decades mapping the molecular machinery of autophagy from the ground up. What his work revealed changed how scientists understand aging, cancer, and nearly every chronic disease. The core discovery is elegant. When cells are deprived of external nutrients, they turn inward. They begin disassembling their own damaged parts, digesting them, and reusing the raw materials. The cell does not waste. It recycles. And this recycling is what keeps it young, functional, and cancer-resistant. To understand why fasting triggers this process, you need to understand two molecular switches called mTOR and AMPK. When you eat, insulin rises and activates mTOR, the master regulator of cellular growth. With abundant nutrition available, the cell focuses on building, making new proteins, dividing, expanding. In this building mode, autophagy is actively suppressed. The cell has no reason to cannibalize its old components. When fresh nutrients are flowing in, as fasting continues, insulin falls. When the cell's energy sensors detect a sustained shortage, AMPK activates and mTOR is inhibited. Now the cell shifts from building to cleaning the damaged proteins that have been accumulating. The dysfunctional mitochondria, the misfolded protein clusters, all of it gets tagged, wrapped in a membrane called an autophagosome, and delivered to the lysosome for breakdown and recycling. This is autophagy in action. When does it actually begin? Current scientific evidence, synthesized across multiple studies, indicates that autophagy begins to rise measurably after approximately 12 hours of fasting, and reaches a significant level of activation somewhere between 14 and 16 hours. It is not a binary switch. It is a gradient. The longer the fast, the more robust the autophagy signal. Research published in clinical literature notes that autophagy peaks during prolonged fasts of 24 to 48 hours. However, 16 hours represents the most practical and sustainable entry point for most people. Long enough to meaningfully inhibit mTOR and activate AMPK, yet short enough to fit into daily life, without extreme effort or nutritional risk. The evidence for what autophagy actually does in the human body is substantial and spans several disease categories. In cancer prevention, a study published in a leading cancer research journal described autophagy as a cytoprotective survival pathway that prevents chronic tissue damage and the cellular mutations that initiate tumor formation. When damaged proteins and mutant mitochondria accumulate and are not cleared, cells lose regulatory control and cancer risk rises. Autophagy clears the substrate of malignant transformation before it can progress. In neurodegeneration, multiple peer-reviewed reviews have confirmed that, in both Alzheimer's and Parkinson's disease, autophagy is the primary mechanism responsible for clearing toxic protein aggregates, beta-amyloid plaques, tau tangles, and alpha-synuclein deposits from neurons. When autophagy is impaired, these aggregates accumulate faster. Neuronal function degrades, and cognitive decline accelerates. In metabolic health, a clinical trial published in a peer-reviewed journal found that 168 intermittent fasting in obese diabetic patients produced significant improvements in fasting glucose insulin resistance measured by HOMA-IR, circulating insulin levels, and HDL cholesterol, compared to a control group. A meta-analysis published in a leading clinical medicine journal confirmed that intermittent fasting produced meaningful improvements in weight, blood, glucose, and lipid profiles in overweight adults. There is also a fascinating connection between a natural compound called spermidine and autophagy. Spermidine is a polyamine found in several foods that directly stimulates autophagy even without fasting. Research published in a peer-reviewed longevity journal found that supplementing spermidine in model organisms, including yeast, roundworms, fruit flies, and mice, extended median lifespan by approximately 10 to 15%. The richest food source is wheat germ, followed by tempeh, natto, shiitake mushrooms, soybeans, and fresh green peppers. Adding even 1 or 2 tablespoons of wheat germ to a daily meal provides a meaningful spermidine intake that complements the autophagy already being activated through fasting. Here is a 7-day plan for building the 16-hour fasting habit from scratch, starting gently and increasing gradually, so that the body adapts without distress. Days 1 and 2 are baseline observation days. Without changing anything, record the time of your first meal and your last meal for 2 consecutive days. For most people, the eating window from the first coffee of the morning to the last snack at night spans 14 to 16 hours. Simply observe. The only behavioral change during these 2 days is to eliminate late-night eating and move the last meal to before 8 p.m. Days 3 and 4 target a 12-hour fast. Finish dinner by 7 p.m. and eat breakfast no earlier than 7 a.m. the next morning. During the fasting window, drink plain water, black coffee without sugar or milk, or unsweetened herbal tea. Nothing else. If hunger becomes uncomfortable, drink at least 300 milliliters of water. A significant portion of fasting hunger is actually mild dehydration, rather than true caloric need. Days 5 and 6 extend the fast to 14 hours. Finish dinner by 7 p.m. and delay the first meal until 9 a.m. the next morning. At this point, the liver's glycogen reserves are largely depleted, fatty acid mobilization is underway, and autophagy is beginning to activate. The first meal matters enormously. Build it around at least 30 grams of protein from eggs, tofu, legumes, or fish, along with healthy fats from avocado or nuts and fiber-rich vegetables like broccoli or spinach. Eat fully and satisfyingly within the eating window. The goal of this practice is not starvation. It is strategic timing of nutrition. Day 7 is the full 16-hour milestone. Finish dinner by 7 p.m. and hold the first meal until 11 a.m. The eating window is now 11 a.m. to 7 p.m. 8 hours. Maintain this schedule consistently for at least 3 weeks following day 7 for the cellular effects to accumulate meaningfully. In the first week or 2, mild headaches, slight fatigue, or brain fog may appear. These are transient adaptation symptoms. As the body shifts from glucose dependence to fat-burning metabolism, they typically resolve within 10 to 14 days. Safety must be addressed carefully, because intermittent fasting is not appropriate for everyone. Anyone currently managing blood sugar with insulin or oral glucose-lowering medications must consult their physician before extending fasting periods, as the risk of hypoglycemia is real and serious. Pregnant or breastfeeding women, adolescents who are still growing, and anyone with a history of an eating disorder should not practice time-restricted eating. Older adults with existing cardiovascular disease should approach fasting protocols gradually and under medical guidance, as some preliminary research has raised questions about long-term cardiovascular risk associated with strict time-restricted eating patterns, particularly in individuals with pre-existing heart conditions. These findings remain under scientific review, but they underscore the importance of personalized medical guidance over generalized health advice. If you feel dizzy, excessively weak, or mentally confused while fasting, stop and eat immediately. If this video gave you clarity on something you had heard about but never fully understood, please subscribe and press the like button. Share it with someone you care about whose health matters to you. Leave a comment below telling us about your fasting experience, or any questions you have. More science-backed content is coming. Take care of your cells, they are taking care of you.